Welcome, guys. So in the previous video that we have already showed that the square root of 2 is irrational, means that the sides of the square and the diagonal is incommensurable, right? So the idea is that we have already proved that AC divided by AB is not irrational. So basically what I want to say is AB and the AC are incommensurable. So there is no such L that AB is a integer multiple of that L, and AC is also that multiple integer of L. Okay, so in this video, let's try to prove another simple case, which is also a very famous, probably the most the most important one. I should say the most interesting. Okay, so suppose you have a regular pentagon. So this is the first, I should say the first irrational number. First irrational number found in the world. So basically, I think it's that guy called this guy, which is a Greek. I think it's the Greek mathematician or something. That is a student of the Pythagoras, and what he proved is that okay, so that's just what he proved is that this guy, this B and the AB are incommensurable. So so it's the same as if you write down the BE divided by AB is irrational. Okay, so this is I think the first irrational number in the world, and very interesting. Okay, and up to now, right, nowadays we know that this BE just, right, if somebody that AB is 1, then we know that AB is just square root of 5 plus 1 divided by 2, right? So this is a famous, like, the golden ratio, which shown in the Fibonacci series. Okay, so the idea of this video, just I will try to prove this fact, and definitely without using the trigonometric function or other properties like the golden ratio. So I will only prove by the same method, what standard, historical, why people can found they are incommensurable. Okay, so let's start. Before I start, hope you guys can subscribe to my channel, because I mean I do math and physics for my channel, and from elementary school to graduate school. Okay, right. So the idea is that let's maybe draw more points. Let's say this is P and Q. Okay, so the proof is that I suppose that AB and BE are commensurable. So So I just use show notation. Okay, so let's say AB and BE are commensurable. Okay. Then what will happen, right? Suppose okay, so let me just finish something. Okay, so the idea is that, okay, so let's say AB and BE are commensurable. Then, but you see, let's say, so you see AB and AQ, right, are the same angle. This can be easily proved because this is 70s, this is 108 degree, right? So this is 36. And also this is 36, right? Because they're all symmetric. So this is also 36, and then this is 36. So this guy will be 72, right? Because right. So this guy was, so this guy is 72. So you see, from here we know that so AB is the same as AQ, right? So AQ, BE are commensurable. Commensurable means there is a such a small L, which AB are the integer multiple of L, and the BE are also integer multiple of such L. Okay, so next is that we know that A, Q, and the BE are commensurable, right? But what it means that QC, what it means is that QC and the BE are commensurable because AQ can minus if I use AC to minus AQ, right? Because AC is the same as BE. Okay, but now so that means this guy and our diagonal, right, is commensurable, but this guy is the same as this guy, right? So that means the middle guy. So that means PQ and the BE are commensurable, right? But this also means that PQ. Let's draw another line here, like this line. Okay. Let's call this is X. Okay. So now we know. Now we want to show that we want to show this, right? You see. So this line is the same as this line, right? So the middle is also a small rectangular guy, right? Small pentagon, right? But this guy is the same as this guy, right? So PQ and we know that BQ is the same as QC, right? BQ is the same as, so PQ and QC are commensurable. The reason is that okay, so let's write down reason. So QC is the same as BQ, right? And the BQ is the same as BQ is the same as QX. So we know that PQ and QX are commensurable, right? But this is contradiction. Why? Because PQ and QX is also sides of the another regular pentagon, but which is this regular pentagon is smaller than the original one. So I mean, you can. So that means somebody can create a smaller pentagon and create an even smaller pentagon, and up to some step, one side of the pentagon can be smaller than original L, right? So I assume that there is such L that A, B, and B are just integer multiple of such L, but now one side of a pentagon can be smaller than L, so contradiction. So that means that the AQ and the BE are incommensurable, which proves that the BE divided by AQ is this guy is irrational. So do not belong to a rational number. Okay, so this is the beautiful proof for a historical guy, a historical fact that which is irrational. Okay, and I will see you guys in the next video. Be sure to subscribe to my channel. Thanks.